beta. So here it says prove that summation EI xi is 0. Ideally, in terms of language, it means that the correlation between the error term and x's is 0. Now, this is one of the assumptions of classical linear regression model that you study as part of the next chapter, where we say that the correlation between the error terms and the xi's, that is assumed to be 0, and its implication itself is that summation EI xi should be 0. Now just try to think about it. So summation EI xi is nothing but xi minus x bar. This is deviation from mean, right? So this is nothing but summation EI xi minus EI x bar, and this will be nothing but summation EI xi minus summation EI x. Now try to notice better that x bar is a constant, and I have always told you constant comes out of summation. So we can go ahead and write this as summation EI xi, x bar comes out, summation EI. And we have already proved in the, in the last video that the sum of the error term is assumed to be 0. So I will go ahead and get this. And we have proved this actually, minus x bar into 0. So this will be summation EI xi. This is what I will be getting. Okay. Now, we know that the error term can be written as the difference between the actual and predicted value of yi. And the predicted value of yi will be nothing but b1 plus b2 xi. Isn't it? So I will go ahead and I will get this like this, that this is going to be summation yi minus b1 minus b2 xi into xi, and this will be summation yi xi minus b1 xi minus b2 xi square. Right, I will just open up the summation yi xi minus summation b1 xi minus summation b2 xi square. Now this b1 and b2 are just constants. So this will be summation xi yi minus b1 summation xi minus b2 summation xi square. Now go to the second normal equation, beta. So the second normal equation that I had told you in the last video, it was this. This is the second normal equation. Summation xi yi is equal to b1 summation xi plus b2 summation xi square. So from here, can't I say that summation xi yi minus b1 summation x minus b2 summation xi square will be 0? So if I just use that fact in this question, from that fact, I recognize that this will also be 0. And that's the proof of it. So in terms of language, as I have already told you, in terms of language, it means that the correlation between error and x's is 0. And just one thing here, So beta correlation में numerator में covariance आता है. तो यहाँ पे x है, ये भी x है. और कोवेरियंस का फॉर्मूला होता है समेशन ई. सपोज मैं एरर का कर रही हूँ, ये ई आई है, तो लेट मी क्लीन दिस अप. तो जिस भी वेरिएबल का कोवेरियंस 0 होगा, व्हेनेवर द कोवेरियंस विल बी 0, द कोरिलेशन विल ऑटोमेटिकली बी 0. And covariance is basically summation ei minus e bar xi minus x bar. So ei minus e bar xi minus x bar, right? And e bar is 0, mean of error is 0. So this is nothing but summation ei into small xi. Xi represents the mean deviation. And we just proved that this is 0. So if this is 0, automatically we are saying that the covariance is 0, because numerator 0 ho raha hai. And if covariance is 0, then correlation is 0. So indirectly we are saying that error term and x's are not correlated with each other. This is what is the implication of this, right? Okay, beta.